Hello, everybody. Welcome to data science class. We are going to be starting with a very introductory part. I'm going to be using this infographic stuff here, material here, to explain every bit of the introductory part. Before we dive deep into data science proper, I would love to explain every concept as to the introductory part so that we get familiar to the terms and terminologies that we're going to be using along the line so that it won't get us confused. Yeah, so by then we would have gotten used to the terms and terminologies. Of course, it is important for every courses. It is important to start from the very introductory, from the very introduction, so that everybody is carried along and everyone gets acquainted with what is to what we are going to meet in the nearest future, as we proceed along the or as we progress in our study. I believe most of us coming here are those that wants to master machine learning, data mining, natural language processing, computer vision, big data analytics, time series analysis, say data visualization, data engineering, uh, business intelligence, blah 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 blah. So it is pertinent to note that everybody is going to be starting um, together. So after 3 months, we are going to split you into various specializations so as to get you focused on uh, whatsoever you are interested in. So, like I said ab initio, I'm going to be using these infographics to explain every bit of the introductory part so as to get us acquainted, like I said before. Okay, looking at this infographic stuff here, we would see that it's separated into two: data and data science. Of course, let's start with this data part. Now, of course, you agree with me from the look of by looking at these infographics, you see that it is split into two. We have the traditional data and we have big data. So they're trying to tell us that okay, data is comprises of traditional data, of course, and big data. Now, before I even try to explain the concept, let me even um, let's assume somebody comes to you, or let's assume you have a neighbor that walked up to you and say like, "Oh, please, can you explain the concept of data science?" What would come to your mind, or what would you think of in respect to uh, data science? Well, let's say uh, data science or data. Let's deal with data. We're dealing with data. So data refers to you can say data refers to raw facts, statistics, or information that can be collected, recorded, and analyzed. It can be in various forms, such as it can be in numbers, it can be in forms like text, images, videos, or any other type of digital or analog representation. So you agree with me that anything can be data, anything stored can be data, can be referred to as data, such as numbers, text, images, videos, or any other type of files or digital any other type of digital or analog representation. You can refer to it as what? Data. So from here you will see that there are two types of data. We have the traditional data and the big data. And let me explain the concept of traditional data. Traditional data simply refers to, let's say, structured and well organized data that can be easily stored, processed, or say analyzed using traditional database management systems such as normal SQL, MySQL, and stuff. So this data is typically generated and collected in a predefined format and has a fixed schema. So they're talking about um, yeah, but what I'm trying to tell you is that the data is typically generated and collected in a predefined format and has a fixed schema. So, of course, by the word schema, you know I'm talking about relational database management system. So, traditional data sources include spreadsheets such as Excel, for example, and of course, uh, relational databases and transactional systems and other structured data formats. When I say transactional systems, what should quickly come to your mind is this QuickBook. I don't know if you've gone to any supermarket and you know you have this kind of they use this kind of QuickBook as one of the transactional systems. Intuit QuickBook. I don't know if you have come across it. It's of course a form of traditional uh, data. Now, when you're talking about big data on the other hand refers to extremely large and complex data sets that are beyond the ability of traditional data. You know, big data, of course, from the word big, it deals mostly in extremely large and complex data set. You know, it deals with data set that traditional data cannot handle, something that are okay data that are very large and big for traditional data to handle. So big data takes care of that. So mm, um like I said large and complex data sets that are beyond the ability of our traditional data processing methods to efficiently uh, uh, handle and manage or analyze it. Now, it is characterized by three V's. Data is characterized by three V's. Here we should be talking about volume. The three V's are the volume, the velocity, and of course, the volume, the velocity, and the variety. Now, when you're talking about the volume, we're talking about the large amount of data, the quantity of data. You understand? Then we're talking about the velocity. Velocity, from your ordinary level physics, simply means the speed. We're talking about the speed at which data is generated. You understand? Then when you're talking about the variety, which is the last V, we're talking about the diversity of data types and sources. You understand? So, like I was talking, like I'm still on deep big data, anyways. Big data encompass structured, semi-structured, and uh, unstructured data from various sources like social media, sensor data, log files, videos, and more. These are example of big data. You know, don't forget, don't get it confused. Traditional data, uh, I give examples like spreadsheet, Excel, transactional systems, which are like, for example, say QuickBooks and stuff. Now, let's explore the differences between traditional data and big data. Now, if you are trying to um, talk about the differences between traditional data and big data, we are going to be looking at the concept of volume, the three V's. We are going to look at the volume, we are going to be talking about the velocity and the variety, the value and stuff. And so I think I should be, I'll try and speak more on the key differences. I think I should be able to pick five out of the key differences. So, yeah, let me first start with the volume. Traditional data is usually of manageable size, typically in gigabytes or terabytes, while big data, on the other hand, involves data at a very massive scale. Like I said, it handles larger data that traditional data cannot handle. So, its kind of data ranges from, say, terabytes to petabytes and even exabytes. So, another V that we've been looking at that differentiates, that shows differences between, that explore the differences between traditional data and big data. We're going to be looking at the concept of velocity. Traditional data is generated and updated at a relatively slower pace. It's when you're trying to generate traditional data, it's so slow. They really, though not so slow as it says. uh we are talking about relatively slow here. Pace, the pace is relatively slow, but it might be something that is not obvious to human visual assessment. You understand? So big data, however, is characterized by high velocity, with data being generated, collected, processed even in real time or near real time. For example, we have the kind of like I gave before, social media platforms generate a vast amount of data every second. The post, the comments, it's all in real time. So another thing we should look at is the concept of variety. Traditional data is often structured and it fits well into kind of predefined database schema, uh, like the MySQL stuffs. So big data, on the other hand, includes a variety of data types such as structured, uh, semi-structured, and unstructured data. Like I said before, you know, unstructured data. If I'm talking about the unstructured data, what I mean by, for example, is let's take a look at social media post or sensor data. You will see that it doesn't conform to specific schema in the database, and it requires different approaches for processing and analysis. I might be sounding a bit nerdy or a kind of a bit. I might be using some sort of terms that uh, you might find difficult to comprehend, but never mind. Don't make it a big deal. What I'm going to do is, after this class, I'm going to, of course, I will include a note. You know, I will include a note that is self-explanatory to support the video, so that it can, you know, to enhance your understanding of what I'm trying to talk about. So the number four thing that we're going to be looking at is, when we're talking about the differences between traditional data and big data, we're going to be looking at the concept of, say, value. you know, Traditional data is usually generated with a specific purpose in mind and is well defined, you know, making it relatively easier to extract insights and value. Big data, due to its sheer volume and variety, requires uh, advanced analytics techniques like data mining, machine learning, and artificial intelligence to extract meaningful insights and value. Then the number five things, or the fifth things we're going to be looking at, I said I was going to be picking five key concepts, key differences that I believe should be able to, you know, uh, cover up or cover for the differences. You know, I see them as the primary. So the fifth one, we're gonna be looking at tools and technologies. Traditional data processing relies on traditional database management systems and structured query language like the SQL, which I talk about for storage. It relies on my SQL, structured query language like SQL. And for example of structured query languages are MySQL, PostgreSQL, and stuff like that, Microsoft SQL and whatever. It uses it for storage, retrieval, and analysis, while big data processes require specialized tools and technologies like Hadoop, Apache, Spark, NoSQL database. Example of NoSQL database is, we're going to be talking. If your example is Mongoose or MongoDB, and of course, it uses distributed computing frameworks to handle the scale and complexity of data. There are much more differences. Like I said, I'm just sticking to five key differences that are very important. So there are much more differences. However, uh, these are just some of the key differences between traditional data and big data. And understanding these distinctions is very crucial for your learning, it's crucial for organizations, and as well crucial for individuals looking to harness the potential of big data for various applications such as business intelligence, predictive analytics, and decision making. And let's try to look into that is that for big data. I'm still gonna be going down, 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 down. I'm still gonna be scrolling down to uh, to explain further using these infographics. But I'm just trying to um, give or explain or give definitions to all these, so as for you to, by the time I'm explaining, you would have had prior a bit some few on knowledge and understanding as to what they do, why you need them, and stuff like that. So let's jump to data science. Since we have talked about data, we're going to be talking about data science. And from the looking at the infographics, you'll be seeing that data science is split into three concepts here. We have the business intelligence, we have the traditional methods, and we have the machine learning. And let me first of all explain what data science is in general. Let me say it can be said to be an interdisciplinary field that combines scientific methods, processes, algorithms, and systems to extract knowledge and insight from structured and unstructured data. By structured data, I mean SQL. By unstructured data, I mean um, something like Hadoop or something like MongoDB and stuff. Now, it involves the application of statistics, of course. You're gonna be, like I said, after this after this introductory part, uh, um, we're gonna be going into some topics or core topics in statistics and mathematics. So it involves the application of statistics, mathematics, programming, and of course, domain knowledge to analyze and interpret data. And it's also, yeah, also to make predictions and solve complex problems. So don't get uh, don't get let me say, I want to say, don't get intimidated by, you know, by hearing statistics, mathematics, programming. I'm gonna make sure that you get every concept of it. God helping me, you're gonna understand every beat. Don't worry. By the time we go uh, into the concept proper, you're gonna have a grasp of what I'm trying to say, and we're gonna be applying it. We're gonna be having it. We're gonna be doing it in practical. So it shouldn't be something that should scare you. You know, it's nothing at all. And data science has three categories, which has been listed here. We have the business intelligence, we have the traditional method, and we have the machine learning. You know, business intelligence, it refers to the technologies, strategies, and processes used to collect, analyze, and present structured data to support business decisions making. You know, and BI most times focuses on, in fact, not most times, all the time focuses on providing historical, uh, current, and predictive views on of business operations through data visualization, reporting, and online analytical processing. Then uh, this traditional method refers to conventional approaches or techniques used in data analysis, typically relying on manual processing and predefined rules. There are methods, I mean, these are methods that can include or that include statistical analysis, data mining, regression analysis testing, and so on and so forth. You know, traditional data requires explicit human intervention, and domain expertise in interpreting and analyzing data. And and we're going to be talking about machine learning. Machine learning, on the other hand, machine learning is a subset of artificial intelligence. You know, what I mean by subset of artificial intelligence, let me first of all explain the concept of subset. Subset is when something is embedded inside something. Let me say, for example, um, uh, when something is inside of another thing, is a subset. So I want to bring it to a very simple term. When you place when you have, okay, the edible coconut, the eatable, if you're taking a look at the coconut, for example, the eatable part is what a subset of the shell. So that is what it means. That is the best example I can give. So machine learning is a subset of artificial intelligence that involves the development of and algorithms and and models that enables computers to learn from data and make predictions or take actions without being explicitly programmed. Machine learning algorithm uses patterns and statistical techniques to automatically learn and improve from experience uh, or data, enabling them to make data-driven decisions or predictions. Now, let's now discuss. Let me discuss. Let's try and discuss the differences of each of these categories, so that again we are going to be looking at five differences, and so that we can have a rapt understanding of um, what we are going into. So here we're going to be looking at the scope and purposes. Let's take a look at the scope and purposes first. So BI focuses on providing historical and current insight into business operations. I have said that before, and of course, this is one of the scope and purpose. And so it helps organizations monitor performance, identify trends, and support decision making. And traditional method encompass a range of statistical techniques used for analysis and inference rather. Sorry. Machine learning, on the other hand, focus on developing algorithms that automatically learn from data and make predictions or decisions. Then, um, number two differences that we're going to be looking at is level of automation. You know, BI involves the use of predefined reports, dashboards, visualization to present data in a structured and user-friendly manner. Of course, it relies on human user to interpret and analyze the uh, presented information. You know, traditional data require manual intervention and domain expertise for data analysis and, of course, interpretation. You know, then machine learning, on the other hand, machine learning uses algorithms. However, can automatically learn. The algorithms can ever automatically learn patterns and make predictions without explicitly programming or without human intervention. Then the third differences we're gonna be looking at is we're gonna be looking at the flexibility. We're gonna be looking at the flexibility and adaptability. BI relies on predefined reports and queries designed to answer specific business questions. Uh, it provides limited flexibility as analysts can apply a range of statistical techniques based on the nature of the problem. Machine learning machine learning algorithms are highly, of course, adaptable and can learn from new data, allowing them to undo complex and dynamic patterns. Then, the number four thing we're going to be looking at is predictive capabilities. Uh, Under predictive capability, we see BI can BI primarily focuses on historical and current data analysis. So without historic, by historical, I mean past. You understand? Past and current data analysis, enabling organizations to understand past performance, and why traditional method uh, can provide insight into relationships and correlations between variables, allowing analysts to make predictions based on historical patterns. Then machine learning algorithms. Of course, machine learning always uses algorithms. So it specializes in predictive modeling, enabling them to learn patterns from data and make accurate predictions or decisions. Then the number five thing we're going to be looking at, which is going to be the last thing here, is complexity and scalability. BI is typically used for analyzing structured data, just like the way I said before, if you can remember. And I said something like, I made example of structured data from database, and I make example from I make use of MySQL as example, which is an example of structured query language, and uh, and and okay, it makes use of structured data from database and structured sources, so making it relatively simpler to implement and scale, while traditional data can handle a broader range of data types and may require more manual effort and expertise. So, machine learning, on the other hand, uses algorithms that excel in handling complex and unsorted data. So, um, I think uh, with these explanations, you should have. Never mind. I'm going to give you a comprehensive note on all the times I've used the definitions and all that, so as for you to have a grasp knowledge of it. So at the end of this lesson, you're gonna be checking your notes. There's a section there where a notepad where you see a note under this video on the platform. So um, I'm going to be dropping a note so as for you to have something to fall back on when it seems that you're not getting it. And of course, you can as well resource from the internet, from the Google and all stuff. So let's look at this infograph together. Um, from data, traditional and big data. So we talked about when is it applied. We talk about it is applicable when an historical data and present data has been considered. So which is at the beginning of your analysis. Then why do you need it? Of course, to make data driven decisions. It require to make data driven decisions that require well organized and relevant raw data stored in a digital format. I gave example of digital formats that can be stored in. Then sorry. Then what techniques are involved? Of course, data collection, pre-processing, class labeling, category versus numerical, data cleansing. Then the techniques involved are e.g. balancing and shuffling data set. Then if we look at the big data here, big data, of course, they still have a pre-processing, of course, then class labeling, text numbering, text, digital images, digital video, data, with digital video data, digital audio data, like I used before, like I said before, then data cleansing, dealing with missing values and stuff. Then case specifics, we have the text data mining, confidentiality, preserving data mining techniques. So, where is it used? Now, look at where is it used. We're gonna be taking a look at under traditional data. It's being used mostly in basic customer data, historical stock price data. All those places. That is where traditional data is being used. Okay, here Big data is being used in social media. Remember, I made mention of that. Financial trading data, I also made mention of that, uh, if I'm not mistaken. Then how or using how using what tools? Okay, how using what tools? What are the tools that are being used in big data? We have the programming language. In the programming language, of course, we're going to be talking about the R, and of course the R, the Python and MATLAB. Of course, SQL is used as the, like I told you, it uses most often uses structural uh, uh, or relational database management, which is SQL. So um, R and Python is used widely in traditional data. Of course, MATLAB too is used. Then the software we're going to be talking about, you remember I said spreadsheet, you know, I gave you example of spreadsheet and relational database, which is SQL and this, the IBM XPSS and stuff. So um, while under big data, we have the R, the languages used are R, Python, Java, Scala, and of course. But we're gonna be in this in this uh, course on we're gonna be using R and data Python. Of course, we're gonna be using 70% of Python, and of course 30%, or if not 20% of R. But Python is gonna be largely used. We're gonna be concentrating more on Python in our later lesson. And of course, the software used, like I said, if you can remember, I said something like Hadoop as a non-relational database. Um, Big data relies on non-relational database because it handles larger volume than traditional data. So Hadoop, MongoDB, and stuff. Then who are the practitioners? We have the under big data, we have the data architect, we have the data engineer, we have the database administrators. Then under big data, we have of course big data architect, big data engineer, and stuff. So let's take a look at uh, let's take a look at uh, the data science here. Under data science, if it, I have explained this to under why it is used to when is it applied applicable. It is applied after the data has been gathered and organized. Then under traditional method and machine learning. So after BI report, after this report have been created and discussed, then of course traditional method and machine learning can now take effect. Look at, I said business intelligence uses uh, past records, historical records, like I was mentioning, to analyze data. While traditional data uh, and machine learning use what? I mean, traditional method and machine learning use what? The future to uh, analyze analyze data. Then why do you need it? Yeah, okay. We need it to use data to create reports. Okay, use data to create reports and dashboards to gain business insights, like I said before. Then why do you use it under traditional and machine learning? We use it to make predictive analytics. We make it to you to make um, to assess potential future scenarios by using advanced statistical methods. Under machine learning, we use it to utilize artificial intelligence to predict behavior in an unprecedented ways. Sorry. Then, what techniques are involved? If you're talking about the techniques involved, we're going to be talking about um, to analyze the data, extract the information under business intelligence, and present it in the form of metrics, KPIs, reports, and dashboards. I told you I've been issued that um, business intelligence makes use of dashboards and reports to explain data. Then um, predictive why traditional methods and traditional method makes use of regression analysis, logistics regression, clustering, factor analysis, time series, and stuff. While machine learning use supervised learning, XVMs, neural networks, deep learning, which is the NN, random forest, Bayesian networks. Then, of course, the unsupervised learning. We have these are under supervised learning, and under unsupervised learning, they use k-means, deep learning, and stuff. Then reinforcement learning, similar to supervised learning, but instead of minimizing the loss, one maximize what reward. Now, where are they used? Well, they are used under price optimization, inventory management. You understand? Under uh, business intelligence. But under traditional method, we use them to create user experience and sales forecasting. Then under machine learning, it is used for fraud detection and client retention. Then how and using what tools? Okay, if you're talking about business intelligence, the languages, of course, involves or includes rather R, Python, and MATLAB, and of course the query language includes SQL, like I said. Then softwares to use, we're talking about spreadsheet, which is Excel, Power BI, SAS, Tableau, stuff like that. Then under traditional method, the programming language to use are R, uh, Python, MATLAB. Then the software to use are IBM SPSS, Excel, that is Excel spreadsheet, eViews, Stata, and stuff. Then under machine learning, we're still talking about R, Python, MATLAB, Java, JavaScript. In fact, C, Scala, and C++. Of course, like I said, we're gonna be solely using Python and R, of course, but largely using Python because Python is friendly and easy to use, so that you won't find yourself in an unnecessary difficulty. Then, who who is talking about the uh, expertise in under BI, under business intelligence? You have the BI analyst, you have the BI consultant, you have the BI developer. They're um, uh, under traditional method. You have the data scientist, you have the data analyst. So the data scientist and the data analyst falls under traditional method. And of course, under machine learning, still have the data scientist and we have the machine learning engineer. So that being said, this is just the introductory part, and of course, it is important to know the introductory part, so as for us not to get confused whenever we start, or whenever we dive deeper, or when we start to dive deeper into um, data science modules. By the time we start talking about or handling situations or problems that involves uh, statistics, mathematics, and you're making references to these terminologies, you won't get confused, and of course, you'd have gotten used to all the things that have been said here. In the next class, we're gonna be diving straight to um, statistics. And like I said, we're gonna be starting with statistics, but it is pertinent and expected that I should um, give an introductory part so as for us not to get confused uh, in the nearest future by the time we start doing statistics properly. So in the next module, we're gonna be as the next lesson we're gonna be talking, or we're gonna be treating statistics properly. I think we should be starting with probability. um, Thank you for watching, and God bless. Thank you very much.